A big part of environmental physiology focuses on improving the health and safety of workers. Indeed, the Harvard School of Business housed a lot of research studying heat stress on worker productivity even as far back as the early 20th century. This question remains an active and challenging field of study. In today's episode, we'll take a look at whether a sudden heat wave affects worker health and productivity, both during the actual heat wave and also in the days afterwards. In this study, 7 young and healthy men stayed in a controlled environment for 9 straight days. The first and final 3 days simulated a typical European summer day, with work temperatures at 25 degrees Celsius and non-work temperatures at 22 degrees Celsius. However, the middle 3 days simulated a sudden heat wave, with work temperatures above 35 degrees Celsius and non-work temperatures about 26 degrees Celsius. During each day, participants did a 9-hour work shift that simulated light manufacturing work. This involved rotations of sitting, light step exercise, then a test similar to inspecting and problem solving on an assembly line. Physical measures like core and skin temperature, along with heart rate, were measured throughout the day, along with their thermal sensation and comfort. Work productivity during that assembly line simulation was measured as the percentage of mistakes made, and participants were also allowed to freely take toilet breaks throughout the 9-hour shift. On the left 2 graphs, we see the core and skin temperature data, with the red days marking the heat wave days. What they saw was a sharp rise in core and skin temperature on the first heat day. On days 2 and 3, core temperature dropped a bit, but was still higher than non-heat wave days. Meanwhile, skin temperature was higher on day 1 and higher again even more on days 2 and 3. This resulted in higher perceived strain throughout the heat wave. The right graph shows the percentage of mistakes, with a sudden rise in mistakes on the first heat day, then a gradual decline over the other heat days, and with return to normal temperatures. Overall productivity also seemed to drop over the heat wave, with participants taking more frequent and longer breaks. So this study showed that worker health can be affected throughout the course of a short-term heat wave. While some physical and performance adaptation occurs, that adaptation remains incomplete. There are 2 major reasons why this study might actually underestimate the overall risk. First, the participants were young and healthy, where this might not be the case with many manufacturing workers. Second, there was very little physical risk with the simulation, whereas in real life, mistakes can result in accidents and injury. Overall, there are a lot of factors affecting heat risk for the worker. Heat can come from both a hot day and working outdoors, but also from indoor work like steel production and commercial cooking. Many jobs require protective clothing, which can add to heat strain by making it harder to get rid of heat. In many industries, there's a continued decrease of fitness and also aging in the workforce, 2 factors that we know separately contribute to increased heat stress risk. Finally, the pay structure of many jobs encourages continued work even when added safety risks like heat stress are present. All these complex factors make heat stress on workers a thriving and critical field of study. I hope that you've enjoyed this look into the fascinating world of environmental physiology. I'm Dr. Stephen Chung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University in Canada. We post new short videos on different aspects of environmental physiology every Wednesday. Thanks for watching. See you next time.